Hello, everyone. My name is, first, thank you for joining this talk. My name is Pawel Wlodarczyk. I'm technical support team lead engineer at Eliatra. We mainly support OpenSearch, so OpenSearch in many areas, mainly security, but also any other plugins, issues, problems with the deployments, migrations, installations, deployments, upgrades, anything like that. So we are actually there for those services. So today's talk is about autoscaling OpenSearch cluster. So there's no such thing out of the box at the moment. So this is actually a short agenda. So the challenges of scaling OpenSearch cluster, what's the OpenSearch cluster, OpenSearch operator is, scaling with the OpenSearch operator, and of course placing it in the autoscaling workflow. So the challenges of scaling start with the data nodes. So scaling the masters or client nodes are not so problematic because they don't handle any data. But if we start playing with the data nodes, upscaling is not such a problem, but downscaling is very sensitive. So leaving the data behind, of course, can cause the red cluster status. So if we kill the primary shard on the leaving node, then the cluster will get the red status, and of course we're gonna have a huge problem then. So there is a manual way we can exclude the node from the cluster and wait until all the shards will be moved. But the problem with that is that we have to monitor all the time. We have to check if the process is actually completed. So basically, it needs our attention all the time during that process. So, the solution, or maybe another way to scale the cluster, is the OpenSearch operator. It brings some automation. It's automation in terms of the deployment, management, the cluster, so we can deploy multiple tiers at the same time. So we can deploy master, client, data tiers at the same time, manage them, scale resources. But still, the scaling requires the manual intervention. So at this point, we have a single manifest where we can define the number of the replicas, but still we need to apply that manually whenever we need that. So either we need to scale it down or scale it up. Now, OpenSearch operator comes with the few features. So there is commands to install the OpenSearch operator inside the Kubernetes cluster. Is quite simple. It's just adding repo and installing the latest or specific version if you need. So as I said before, OpenSearch operator has multiple features, deployment and security configuration, so you can manipulate the cluster as much as you want. But the main features that I actually want to focus today are the smart scaler, so the draining the node before leaving the cluster, and operator monitoring. So what we get with the operator is the ability to install the service monitor for the Prometheus operator. So in that way, we don't have to manually configure each node that we add to the cluster to be visible by Prometheus. So once we add the new node to the cluster, once we're scaling up, the node will automatically be configured with the specific label, and then Prometheus will pick it up, and the metrics will be sent directly to the Prometheus. So so scaling with the OpenSearch operator, as I said, it brings us, it simplifies the process. So it allows us to use the single manifest and then OpenSearch Operator will monitor this process as well if we are downscaling. So if we have not enough, let's say, replica, so we have more replicas of the index than we have the nodes, then basically operator will keep waiting until have enough nodes to drain the nodes. So either we will change the index to out-expand, or we will decrease the number of replicas. So definitely OpenSearch Operator with the smart scaler option won't allow us to bring the cluster into red status. It will wait forever until it's fully satisfied with the moving the data. So to automate the process, we can place the OpenSearch Operator in the bigger picture, which is the GitOps and monitoring of the metrics of the OpenSearch. So GitOps is needed to have a single source of the truth for our OpenSearch Operator manifest. The monitoring is required to trigger the change when we need to either downscale or upscale the cluster. So the first part is the ArgoCD in this case. So actually, this first is actually the GitLab. We can use the GitLab, GitHub, anything that will give us ability to store the manifest and keep the tracking on it. So in this case, I used the GitLab, but I was using also GitHub for that. Then we can configure the ArgoCD with the that will point to this manifest, and it will push the manifest into the OpenSearch Operator, which and then OpenSearch Operator will basically create the cluster. So this is the let's say basic configuration. Of course, the OpenSearch Operator manifest is much bigger. So I just make it a bit shorter. So the most important things here are the part regarding the smart scaler. So it's set to true. There's also drain data node set to true, but this is mostly used for the rolling upgrade process. So whenever we do that, the operator will drain the node before upgrading the node. The other part is the Prometheus exporter, because we have to export our metrics somehow. So in this case, we're using Prometheus exporter version. So this cluster was built with the version 3.2. There was a small block, let's say, on supporting latest versions, but since August, OpenSearch project took care of the Prometheus exporter. So the versions now are up to date. So we can use that for exporting the metrics. And the other part of that is the monitoring Prometheus. So we can see there is a label set for it will be set for each node. So whenever the new node or any node will be created, it also will get the label for the monitoring. So the Prometheus operator will pick it up, and we will see the metrics inside the Prometheus. So the workflow is, of course, to create the application in ArgoCD. So once we have the manifest, so you see there's a source that is pointing to the Git, and then we can pick the path to the file that we want to deploy. And then there's a target, which is the Kubernetes cluster. And at the bottom, we have the policy for sync policy for the ArgoCD. So we can either choose a manual or automated process. So it depends if you are testing or you already have a live environment and you want to just run it. So in this case, ArgoCD has some default interval. I don't remember how big is that. It will just pick the changes from the GitHub, from the source, and it will apply to the cluster straight away. So you don't actually have to do anything with that. So the next steps will be creation of the object for the OpenSearch operator. So it's called OpenSearch cluster with the manifest that we sourced from the GitLab. And at the end, we will see the full deployed cluster, OpenSearch cluster, of course, with all the secrets, objects. That will give us the full picture of what we have inside the cluster. Of course, we can click on any of the objects and just see first the content or the logging if we need to see how far the nodes are actually running. So if they're actually already up and running or they have some issues, so we can still monitor at this level. So once we have a cluster deployed, we have a second part, which is the monitoring. So in this scenario, we have Prometheus Exporter as the tool that exports the metrics. Then we have Prometheus Operator that deploys Prometheus and Alert Manager. With that, we can also connect Grafana, which is not so complicated. The good thing with the Grafana is that we can see metrics, live metrics, in the nice, let's say, GUI. We can actually choose which metric is the one that we want to use for monitoring the cluster. So when you look at the when you look at the metrics that comes from the OpenSearch, you'll notice that there's plenty of them, plenty of metrics. So it's just need to be, it's easier actually with the Grafana to find the one that you are interested in. So Prometheus Exporter comes as a plugin, as I mentioned before. To verify that is installed, you just run the command for the OpenSearch plugin list. So you will see that at the bottom you should have Prometheus Exporter installed. So as I mentioned before, Service Monitor is created for this cluster. So whenever we deploy a new node with a specific label, with this node will be picked by the Prometheus, and the metrics will be collected. So this is the example of the. I'll show you that in the demo later on. But this is just the example of the Prometheus with the status of some of the nodes. So as you can see, we have multiple labels here. Also, the labels are set for the type of the node, so we can have a data master, also the cluster name, and of course the label for the Prometheus. So the next one is the Prometheus rule. So here we're gonna define what actually we're looking at in the metrics. So when we want to trigger our scale down, scale up operation. So in this case, well, as I said before, there's so many metrics. So in this case, I choose the OpenSearch cluster shards number. It's average actually per cluster. The number is just the number is low because it's my own cluster running on the Mac, so the values are not so high. But of course, when you go to the production environment, those numbers will definitely change. So here we can set how long we're gonna wait for the so how long the Prometheus has to monitor the specific metric. So when it's triggered, it will be waiting, so it will get the pending status, and it will be waiting. Once it will cross the interval, it will actually initiate. It will trigger the alert. So then to actually move from Prometheus to alert to the alert manager, so trigger alert manager, we need alert manager itself, and make the connection between the alert defined in the Prometheus and the webhook that we want to send to Argo events. So in this case, you see there are two links or two URLs. They're pointing to the service. It's easier to use the service than expose the ports outside. So in this case, I use the service for the alert manager. Sorry. Yeah. So that is for the events, and then that will go either scale up or scale down. So I'll show you in a minute why is that. Um, so now we're moving, so that is the monitor. So we are at the stage where the alert manager got the alert, and it triggered a specific scale up or a scale down. So we're moving down the tree to another set of the tools, which is the Argo event sensor and the Argo workflows. So the first is the Argo event, so event itself. In there, it's very similar to Ingress, where we're actually setting a different path for different endpoints. And in this case, I set like a separate endpoint for the scale down and the scale up operation. Also, we define the post, so the methods of the this API, which is the post in here. So once we trigger that, we get to the sensor, and the sensor has a connection to the workflow. So once we pick the correct sensor, either a scale up or a scale down, we will use either of these workflows. So the most important part is the bottom. So as you can see, it is not so, I'd say, complicated in here. What we do, or well, actually, I decided to do, is pulling the Git repository, finding the document, change the value of the replicas for the data node, and just commit that, and send back. This operation is actually quite fast because there's no much data. It's just a file. And once it's that completed, the change is visible then in the GitLab, GitHub, whichever you use. And then, so this is the operation so this is the executed either the scale up or scale down operation. If you look at the Kubernetes pods, you will notice that Argo Workflows actually runs the pod, and that pod does all the commands inside, and then it has a status completed. So the thing I found that is the Argo doesn't clean that, so we have to find the way or script or the way to clean the completed task, because if it's gonna be often, you'll get like quite big list of the completed tasks. So this is the updated, this is the updated Git repository. So the replica set has changed to 3. I'm gonna show you that also in the demo. And at the end, ArgoCD will pick up automatically. It will pick up the change. It will find it's out of the sync. We will be able to see that also in the diff view, that the replica number has changed and it needs to be updated. So in this case, when you have the ArgoCD set to auto, you basically don't have to do anything, just wait. Again, I didn't find the interval. Probably there is a way to change the interval to be more, to be shorter. So let me show you the demo. So this is the link to my GitHub. So what I did, I put the list of all the components, how to install them, so you can build this workflow by yourself and test it. I hope this will. I hope that will work. This from the description, but test it a couple of times. So I run it on the K3, on the K8s, and also on the Docker desktop, the Kubernetes Docker desktop. Let me just move that. It's going to be interesting. So let's go into this part. So currently I'm running that on the Docker desktop on my Mac. Everything is actually running quite smooth until I actually go crazy with the number of the OpenSearch nodes. But this, in here you can see it's a deployed cluster. So I actually use the ArgoCD to deploy multiple things. So it's deploy the monitoring, deploy OpenSearch Operator as well. But also, you see here, I have two different cluster. I can do either manually here or do the auto. So auto is up to date. And of course, here you can see all the nodes deployed with the, so we have a data and master nodes. So now, this is the metric I used for the, I hope do you see that or is it too small? It's okay. So this is the metric I used for the, for this cluster. So the Prometheus is actually, just a sec, I'll show you the Prometheus as well. So here is the cluster. So you see here we have 6 nodes at the moment, 3 master, 3 data nodes that are actively monitored by the Prometheus. And, yeah, sure. Is better? Okay. And here we have two OpenSearch, scale down and scale up rules set in the Prometheus. So that's the manifest I showed you before. So one is set for 6 at the moment, and the other one is for 11. So again, you can manipulate that. You can update this through the kubectl. This is just the object in the Kubernetes. So at the moment is in the state of the over the 11 because I create like 20 indices. But once I will delete that, so let me just, that is delete. Okay. Once I will delete that, I should see the change in the trigger. This also takes a small bit. So once we'll see that it will actually turn, the top will turn into green, the bottom will change into first pending, unless it doesn't like me anymore. So we see a metric has changed. It went now below the, all right. So now you're, now you went to sim, okay. Sorry. Okay, so let's go the different way then. Because we set the value for 6, this is actually going to be green all the time. Now it's pending. Okay, so it's switched, and now it's monitoring it until we'll get the pass. So this is set for 1 minute. I just made that shorter. I don't know if there are possible seconds in it. Probably there are, but I actually didn't go that far. So we can see what the value is, and then it's basically waiting now. So it should, in a minute, it should trigger the alert. Once the alert is triggered, we should see that, we should see that alert in here. So we got cluster down, so scale down operation. And now when we move into ArgoCD, Argo workflows, we will see running scaling down process. So now we can see the logs, what's happening inside. We see that workflow has pulled the Git, changed the value, and committed that change back to the Git repository. And then we can check that value also here. So this is the original value here, which is, is that the one? That's 3. And that should change now to number 2. I think I did. I don't see from here. So at the end, we have the ArgoCD that will actually pick this change. So at the moment, we have to wait for that to change the value, and we should see a one data node less in the cluster. So basically, this is the whole idea. I know it looks big, it looks complicated, and it looks more like a POC. But at the moment, there is no actually out-of-the-box solution that actually gives us auto-scaling. This is an idea. So of course, you don't have to use ArgoCD. You don't have to use Prometheus. You can use GitHub Actions instead of the Prometheus and build some scripts around that to automate the process of the monitoring. Of course, you can use the OpenTelemetry if you find the metrics that actually works better for you from the OpenTelemetry instead of the Prometheus exporter. At the moment, the trend is to keep the Prometheus exporter until OpenTelemetry is mature enough, and then the switch will happen. So there's an RFC on the GitHub regarding that. Also, you don't have to, I mentioned that you don't have to use the ArgoCD. You can use the FluxCD, anything that automates this. So this is just more like a schema that you could think about, and more like convince you to use the OpenSearch operator in this scenario, so we can actually automate the scaling process. So this is I think it's one of the pain points in the OpenSearch cluster management. So if you're on-prem, well, it's not a big problem. But if you are like on AWS or any other cloud service, the cost does matter for you. So I think it would be good to have something that allow you to downscale, upscale when you need that, so just to reduce the cost. And that would be, sorry. Yeah, and that would be it. So if you, sorry. So that's our contact, of course. You can find me also on the OpenSearch forum. I'm there quite often. So you can ask any questions over there. This also can regards the ArgoCD or this deployment or the OpenSearch, mostly OpenSearch issues. Yeah, so any questions? I'm sorry? Different from Kubernetes from what? HP. I haven't heard that one. Sorry. No, I just use with the Kubernetes. So mainly because the operator works on the Kubernetes, and like it's because the operator is designed for that. Yeah.
I just realized you posted Pawel, so now I recognize you.
Thank you.
I was wondering, so around the Kubernetes operator, I know that the community seems to be sort of split. There were a couple different forks. It seems like has the community sort of consolidated now against the
Yeah, so the OpenSearch operator is actually run by OpenSearch project. So I've heard about a couple tries of forking it, but yeah, OpenSearch project took it, and they're maintaining that. So we're actually one of the maintainers of the OpenSearch operator at the moment. Yeah. Yeah.
Thank you for your enthusiastic activity on the forum.
Thanks.
I have a question about the rolling updates or rolling restart with Pawel. I mean, data for cluster manager.
So
Change the number of replaces. I believe it will start rolling operator or restart simultaneously.
well, number of the replicas shouldn't cause the rolling upgrade. That's two different operations, I'd say, unless you change the version and then it's changing that. I know I know, I think in the Helm charts that when you upgrade, when you make the initial installation, then you do upgrade of that installation, it might restart master nodes because it's removing the cluster initial master configuration. That's per Elasticsearch book. So whenever the cluster is formed, you shouldn't use those configurations. But I don't remember if because I've seen the scenarios where the data nodes also had that cluster initial master with no reason, because this is only needed for the master nodes. Well, if you change the name of the Docker image, that's different because you're upgrading the pod. So you're just using a completely different image. So we're moving then to the upgrade. So that's actually natural. So and that will do in specific order. So it should start with the data nodes and then do masters, as far as I remember. But yeah, that's the upgrade. So replica set is different because replica adds or removes the nodes from the existing cluster. And it doesn't change anything else. Even if you had, well, if you would change anything in the OpenSearch YAML, then we're talking about the rolling restarts. So then, yes, you would see the restarts of each pod in the cluster, but not with the replica set.
Does the operator now support availability sound, rack awareness, like a self-hosted?
I know there's affinity rules and all of that in the operator. Operator has so many options over there. I've seen huge configurations over there, but again, like once you configure that, because like I've seen some forum cases where people are complaining that the data drain doesn't happen for the cluster, but also I've noticed at the same time they have affinity rules, so they might affect the whole process. So once you put that kind of a complexity, you just need to be aware that there's another decision made behind that, so before the data are moved. Yeah? With a fresh cluster, it might happen once. So what I always do, like if you're in the production, you're deploying a new cluster, it is good to do even like a dummy upgrade, just to see that the cluster, if there is any rule that removes extra options from the OpenSearch YAML, for example, so then you definitely will get the rolling restart of everything. So I don't remember if the data has an operator. I didn't check. I will have to check in the OpenSearch YAML if that is actually adds there. But yeah, so it's good to run the first one, and then you should be OK. It shouldn't cause any other restart because you don't change anything else. But the cluster initial master is needed for, and I think it's a discover as well. These two are required for creating the cluster, and then they are not needed for that. So Elasticsearch says to remove that from the, well, in that case, Elasticsearch YAML, but also OpenSearch YAML, same. OK, any other questions?
Last one. I think early on in one of the first slides in the OpenSearch Operator config, I think there was a drain node config option, and I think you made a mention that it was used during an upgrade that would also drain the node?
Yeah, so.
What's the upgrade, I guess the rolling upgrade methodology is the operator. How does that sequence?
The sequence is that the masters are at the end, as far as I remember. Data nodes are first. At least that's what I saw when I was doing the upgrade with the OpenSearch operator, and I hope it didn't change since then.
I think it's adding a new pod with a new version, and it's just draining off the old, and it will kill the old pod once it's drained, or?
Yeah, that should be the idea. So it's basically, well, that's what it is with the Kubernetes. When you change anything, like if you change the image, you're basically killing the existing pod and you're creating the new one. That's the difference between the Kubernetes and the Docker, where you can actually restart the whole thing and redeploy with the new image. But yeah, overall is the part. Well, with the Docker, we actually removed the container as well, as far as I remember. But yeah, this is basically terminates the existing pod and creates the new with the new configuration. But because it's a stateful set, it connects to the same data, so you don't lose the connection with that. Yes, that's the whole idea of the stateful set. So stateful set keeps the numbering of the pods, so the naming of the pods must remain the same. And the name of the pod is assigned to the data, to the PVC, so they cannot be different. So that's the Kubernetes object. That's not operator. Okay, any other questions? Okay, thank you very much.